x is always the midpoint. So the mean is normally calculated as the summation of fx over the sum of the f's. And then by doing that, the mean will be obtained. So your task in this particular kind of a question is for you to get the x values, which is actually the midpoint. And we say the midpoints are obtained by adding the lower limit to the upper limit, and then you divide the solution that you get by 2. So if it was a class of 0 to 5, the midpoint will be 0 plus 5 divided by 2, which would be 2.5. If it was a class of 5 to 10, the midpoint will be 5 plus 10 divided by 2, which is the same as 15 divided by 2, which will give you 7.5. And then the frequency will be given, maybe this is 2, this is 4, like that. Then you go and get your fx, which is simply the frequency of that class times the midpoint of that class will give you the fx. In this case, this one will be 5, this one will be 30. Then you add the fx's. By adding the fx's, you get the sum. Remember, we say this means the sum. So you will add this to get the sum of fx to be that 5. You also add the sum of the x to have it as 6. Therefore, the mean, which is given by x bar, will be equal to that 5, which is the sum of fx, divided by 6, which is the sum of f. And that actually will give you the answer comfortably without any struggle. So anytime you are asked to determine the mean, get the fx, get the x column first, and then the fx, add all the fx's values down that particular column, and then you divide by the sum of all the frequencies, you are able to get the mean. When it comes to the median, we saw from our discussion that the median is normally obtained by L plus n over 2 minus c divided by f, and then you multiply by r. That is what we say. And we say, anytime you are calculating the median, you must get what we call the cumulative frequency. You must create the cumulative frequency. You must create the cumulative frequency, which is normally denoted as the CF. Cumulative frequency is the CF. So, in this particular question for the median, after getting the total frequency, you can be able to locate the median class. You can be able to locate the median class, and the median class we say is obtained by dividing the total frequency by 2, so that now you can take that particular value to the cumulative frequency to be able to determine the class where the median value is going to lie. You do n over 2, that will give you the halfway mark, and this value that you get here, you take it to the cumulative frequency, you will be able to identify the cumulative frequency where the median is going to lie, and then from that, you can go to the left and pick that particular class where the median is going to lie. After getting the median class, the lower limit of that class is the L. N over 2 is what we did here. C is the cumulative frequency above the cumulative frequency that you have selected. And then F is the individual frequency of that class, and I is the class interval or the class width. That is what we did last time, which was on Wednesday. So in this particular class, our focus will start by knowing how we can create the mode of the group data. Remember again, we have got 2 types of data. I said we have got the ungrouped data where the values are just listed, listed like that. This is an ungrouped data. For the mode, you just pick the value that is time repeated. maybe you have things like that. Because 9 is repeated by any other, therefore the mod is going to be just 9. The value that is most repeated, you just observe, and it does not involve any calculation. You just observe which value is the most repeated. And then that same value is going to be your mod. But now, when we have got group data, remember group data, we said it is data which has been organized into classes, like a class of 0 to 5, 5 to 10, 10 to 15, 15 to 20, and so on and so forth. When the data is organized in this manner, and then you are given the frequency, frequency in simple terms indicates the number of values that are within this range, the number of values that are within 0 and 5, how many numbers are there? You call them the frequency. For that particular kind of data, the mod is normally calculated by the following formula. The mod is calculated by the following formula. And it says that mod is equal to L plus FO minus F1, this part divided by twice FO minus F1 minus F2, then you multiply by R. That is the formula for getting the mod when it comes to group data. And in this case, L is the lower class limit, the lower class limit of the model class, L is the lower class limit of the model class. FO is the highest frequency. F1 is the frequency above FO. F2 is the frequency below FO. And then model class is the class with the highest frequency. And the highest frequency, remember, it is FO. The class where FO belongs, it is going to be the model class. It is a very simple measure of central tendency because in this particular kind of a question, you don't have to create any additional column. You don't have to create any additional column. Like for example, for the mean, we must create X and FX. For the median, we must create a cumulative frequency. For the mod, the way the classes are going to appear, they are going to be enough. We don't create any additional column. We just work with the question the way it is. So here, let's recopy this question and use it. you are given a question like that, or you are given the table like that, and then you are told, determine the model salary. Determine the model salary, or the salary where majority of the employees are earning. Majority of the employees are earning, or which salary is being earned by majority of the workers. So that salary is going to be the model salary. So in this question, what you need to know, or what you need to do, is to identify the values that you need in your formula. If you can look at your formula, you need L. You need L, but first of all, you cannot be able to get L before you locate the model class. You locate the model class, and after locating the model class, the lower limit is your L. So the key thing here, or the underlying aspect that is going to make your life to be very simple in terms of calculating the mod, is for you to be able to determine the FO. If you are able to get the FO, all the others now are found. The FO we don't need to calculate, we just observe. The highest frequency, remember the number of employees is our frequency. Okay? The highest frequency of all, or the highest digit in this particular column, it is our FO. As we have said, FO is the highest frequency. So in this question, you realize that our FO is actually 24. 24 is the highest value that we have there. After getting that, this is our FO. It simply means that this particular class, where 24 belongs, is the model class. So the model class is going to be equal to 20 to that. 20 to 30 is our model class, because this is the class that has the highest frequency. After doing that, then L will be equal to 20, the lower class limit of the model class. So I hope you can be able to follow the sequence that I've done. The first thing is to locate the FO, which I've located it to be 24. If 24 is the FO, or the highest frequency, the class where 24 belongs, which is 20 to 30, is our model class. If this is our model class, then 20 is our L, because L is the lower class limit of the model class. And if this is the model class, this is the lower class limit, this is the upper class limit, we pick the lower class limit to be our L. Then from there, you identify the F1. F1 is the frequency above FO. So F1 will be the frequency that is above FO, which is 4. The frequency above 24 is 4. F2 is the frequency below FO. Frequency below FO. In this case, the frequency that is below 24 is actually 16. Like that. So, and I is the class interval. In this case, 30 minus 20 is actually 10. And now you have all the values that you need for you to be able to calculate your mod. So in that case, then what is the value for the mod, or the model wage? The model wage will be given by the mod will be given by L, which is 20, plus FO, which is 24, minus F1, which is 4, over twice FO, that is twice 24, minus F1, which is 4, minus F2, which is 16, then we multiply everything by 10, which is R. So this one will be equal to what? 20 plus 20, that is 24 minus 4 is 20 over 48 minus 20. Negative 4, negative 16, the same as negative 20. Then we multiply by 10, which will give us 20 plus 20 over 28 times 10, which will be equal to 20 plus what? This is the same as 200 divided by 28. What do you get, Damaris? Somebody to work for me this part here. 20 over 28 times 10.
$7.14.
Sorry?
7.14.
7.14.
Or not? Yes.
So the mod is going to be 27.14. 27.14. Let us have another illustration of the same. Another illustration where you are given the height in centimeters, and then you are also given a number of students. So here you are given 140 to 150, 150 to 160, 160 to 170, 150 to 190, 190 to 200, 200 to 10, to 10, to 20. So we need to use this particular information for us to be able to calculate them all. So the frequencies are given as 3, 9, 32, 72, 8, 36, 12, 6. Now the question is for us to calculate the mode. So the mode is simply calculated by, first of all, identifying the highest frequency, which is our FO. We identify our FO. Our FO is the highest frequency. Just go to the frequency, identify the highest, which is 8. After identifying FO, identify the model class. Model class is the class where that highest frequency belongs, which is 180 to 190. In that case, the lower limit L is going to be 180. The lower limit of that particular class is your L. And then from there, you can identify F1, which is now the frequency above the highest frequency that you have picked. F1 will be equal to 72. F2 is going to be the frequency below the highest frequency. In this case, the frequency below 8 is 36. And then I is the class interval. The class is 180 to 180. The class interval is normally the difference of the two. The higher frequency, the higher limit minus the lower limit, which gives you 10. And then after getting those values, go and apply them in the formula. Apply them in your formula here, and then you get the mode. I give you only 2 minutes. You try that, or you finish that, and then we proceed shortly. I hope you are now done. It's just a matter of substituting now the values that you have on the formula, and you get your mode. So, having understood how we calculate the mean, median, and the mode, both for grouped data and the ungrouped data, we don't have any other business to do with the measures of a central tendency. We are done with the measures of central tendency, and therefore we need to proceed to the next area. And the next area that we are heading to is on the area to do with the measures.
Mwalimu, tuambie the correct answer for that one.
The area of the measures of dispersion. Measures of dispersion. I don't know. Esther is saying that she got 181.5. I don't know. I have not calculated that by type series because I know you are always sharp. You cannot be in a problem to fix this in the formula. You cannot be in a position to fix this in our formula for you to be able to get to the mode. Then Linda has actually agreed on the same. So the answer is 181.5. So if that is the case, then we proceed to the measures of dispersion. So the dispersion here, dispersion is actually the variation. Dispersion is the same as the variation, whereby the values that we have in a distribution, we want to measure how far are they from the measures of central tendency. Remember, we started by saying that a measure of central tendency, that is either a mean, mode, or median, it is that one single value that is a representative of the entire set of data. That one single value that is a representative of the entire data is what we call a measure of central tendency. So when, for example, students do an exam and then we say that the mean score is a certain percentage, then we generalize and we say that the general performance of the class is that particular mean score. But reality is that that particular mean score was never attained by everybody who sat for that particular exam. So when we come here and we say that the mean score is 55% of a particular exam, that does not mean that everybody scored 55%. That does not mean. But this one value, even if there were 100 students, we normally say that this was the performance. The performance of the class was a mean of 55%. And actually, that is taken to be the general performance of that class. But ideally, and from the factual point of view, that is not actually going to be the case, or this particular score is not the score for everybody. Yeah? So we want to measure now how correct is this particular overall figure going to be a representative of the actual values of that particular distribution. So you can find that this is the mean score, that is 5%, and maybe there were only 5 candidates, and they scored 55%, 55%, are 1, 2, 3, 4, and the fifth one also scored 5%. If all of them scored 55% like that, then we can sit back and say that if the mean, remember the mean now, is going to be 55 plus 55 plus 55. 1, 2, 3, 4, 5. We add and then we divide by 5 goes to 5. And then actually we find that this one will be 5%. So from this particular case, you can be able to see that the mean and the values which are now called x. Remember these actual values we normally call them x. So this is x1, x2, x3, x4, and x5. You can be able to see the mean, which is normally denoted as x bar, and the x values, they are actually the same. If that is the case, then there is no dispersion, there is no variation. And this particular measure of central tendency, which is 55%, it is actually a perfect one, and it is a true representative of the data the way they are. If this is 55 and the actual values are also 55, then there is no any dispersion, and the values are actually said to be correct or perfect. So, but does this normally happen in real life scenario? No, they don't. So you can come here and say that the mean is 55, but when you go to the actual scores of the students, the 5 of them, you can find that there is a student who scored maybe 50%, another one scored 5%, another one maybe scored 16%. There is another one who scored maybe 48%, and there is another one who scored 62%. If you add these values and you divide by 5, you will find again that the mean score is going to be 55. You will find that if you add 50 plus 55 plus 60 plus 48 plus 62, then you divide by 5, actually you find that the x bar is going to be equal to what? 55%. So we are saying that the mean score is 55%, but when you go now to the actual data, this is x1, x2, x3, x4, and x5. You compare this one and this one, it is only one student who scored 55, the others, they never scored 55, so there is variation. So there is a variation. So like in this case, the variation or dispersion B is normally obtained by the actual x value minus the mean value, which is now the x bar. We want to measure how far are these values far from the mean. So the x minus x bar for the first one is going to be 50 minus 55. So there is a dispersion of -5. This one, it is 55 and 55, there is a dispersion of 0 because 55 minus 55 is 0. This is x minus x bar, 60 minus 55, there is a dispersion of +5. 48 minus this one, there is a dispersion of -5, and the 62 minus 55, there is a dispersion of +7. So when we talk about the measures of dispersion, if there is no dispersion, then that particular data is said to be very, very accurate or very truly representative. When the dispersion is very small, when you find that yes, there is dispersion, but the dispersion is not of big margin, then we say that the value, which is now the mean, it is almost becoming the true representative, and there is a very small variation, so we can rely on it. In some cases, the dispersion can be very big. You can find a very big dispersion, like maybe the following demonstration. You can find a case where the scores of the students are, there is a student who scored 95, there is another one who scored 55, there is another one who scored who's called what? Maybe 40. And there is another one who's called 65%. So if you look at this particular kind of data, and we come here and say that the mean, which is now x bar, is going to be given by 95 plus 55 plus 15 plus 40 plus 65 divided by 5, you still get that the x bar is 55. If the x bar is 55%, the mean, and you compare with the x bar and x bar, you'll find that this particular mean, it is not actually portraying the real picture, or there is a lot of lies. There is a lot of lies here. You cannot say that the mean is 55 and you say that this is the general performance of the class when there is somebody with 95 and there is somebody with 15%. These people are very far away from the mean, and actually they are not represented here. They are not represented here. So we can say that this mean is not giving us the correct picture, the way things are on the ground. On the ground, things are different. When somebody tells you that this is the performance, but when you go and ask for the actual performance of each and every student, you find that this was the scores. You find that then this mean is misleading. So when we try to calculate the measures of dispersion, we want to find out how far is the mean becoming or should be treated as the representative of the entire data. If you find that the mean and all the values are the same like we did here, then the data is very perfect, and actually the mean is actually a correct or true representative. When you find that there is some form of dispersion here, if you use this particular data, there is some form of dispersion, but the dispersion is not that big. From 50 to 55, the dispersion is very small. From 60 to 55, the dispersion is quite small. We can say that this particular data can be relied on, and we can actually make decisions using this particular data because the dispersion is very small. But for this particular kind of example, the dispersion is very big, and therefore this mean is misleading us. The mean is misleading us, and it is not a true representative of values the way they are in the actual sense. So, having given you that particular breakdown of what is a measure of dispersion and what they normally do, then it is my responsibility now to show you how do we calculate the measures of dispersion, or how do we calculate the dispersion using the different methods that we have. But I want you now to understand that when the dispersion is very small, then the data is correct. When the dispersion is very big, then the measure of central tendency is not correct, or it is misleading. So allow me to go to the methods of calculating measures of dispersion. Methods of calculating measures of dispersion. The first method that we have, the simplest, is known as the range. The range is the first method that we shall look at, and actually we go explaining them. The range is the difference. Between the highest value, and the lowest value. The difference between the highest value and the lowest value in a distribution is what we call the range. But remember, regardless on the method that you're using, the smaller the measure of dispersion, the better. Like for example here, if you are told to get the range will actually be 0, because the highest and the smallest value, they are all the same. So the range is actually 0, and that data is very correct. Just a minute. In this particular kind of an example, the range is actually going to be 0. And when the range is 0, it simply means that that data is very accurate, and the measure of central tendency that is going to be calculated for this, that measure of central tendency is actually a true representative. Remember, in this particular kind of data, you can see the mean, which is going to be 55, is the same as the median. If you arrange this data and you pick the median number, it's actually going also to be 55%. The mod is also 55% because that is the value that is highest repeated. So you find that when the range is 0, it simply means that the mean, the mod, and the median, they are actually the same value, and that data does not have a higher value and a lower value. All the values are the same. When we go to this particular data here, if we are told to get the range, you come here and say that the range is going to be given by the highest value. You realize that the highest value is 62. The highest value in this distribution is 62. Therefore, the range is going to be 62 minus the lowest value, which is 48. So these values, in simple terms, they range from 48 to 62. They range from 48 to 62. And what is the answer for that? You find that the range is actually 14. So the range in this case is going to be given as 14. For the other data that we did, you find that the range, for the other data that I've just done here, the range is going to be the highest value was 95 minus the lowest value, which is 15. You realize that the range is very big. The range is very big to the extent that it is actually 80. The range in this particular case is 80, which is very big, and that's why we say this dispersion being very high, then the mean cannot be considered to be a representative for the entire data. So the first and the simplest method of calculating the measure of a dispersion is the range. And as I'm saying, the range is calculated as the difference between the highest value and the lowest value. So for ungrouped data, this is how you do it. Just pick the highest value, you minus by the lowest value that you pick, the answer is actually the range. The answer is actually the range. The next question maybe somebody might ask, what about if it is grouped data? If it is grouped data, how do we come up with the range? So for grouped data, the range is normally given by this is for the grouped data. And remember, anytime we mention the word grouped data, what should come at the back of your mind is that it is data that has been organized into classes. Data that is organized into classes from the lower limit all the way to the upper limit. So the range is the upper limit. It is the upper limit of the highest class. The upper limit of the highest class minus lower limit of the lowest class. The range is given by the upper limit of the highest class minus the lower limit of the lowest class. So if you are given data like this, maybe it's talking about the max. Maybe it is 0 to 10. Let me not use that. Let me say maybe it was starting from 10 to 20, 20 to 30, 30 to 40, maybe 40 to 50. That is actually how the marks were spread. And then you are given maybe the number of students which will be our frequency. Maybe this one we were 3. We had 3 here, we had 5, 8, maybe we had 6. Now you are told what is the range. The range, we have said, it is the upper limit of the highest class. The upper limit of the highest class. The highest class is 40 to 50. That is where now those who scored the highest marks are going to be here. The highest class is where we are going to have those who have got the highest. Even if it is marks, the highest marks will be in this particular class. So if that is the highest class, you take the upper limit. In this case, the upper limit is 50. Then you minus the lower limit of the lowest class. The lowest class is this. Those who scored the lowest marks are going to be those who scored between 10 to 20, because that is where the classes are started from. So the lower limit of the lowest class is 10. So minus 10 like that. So it is the upper limit of the highest class. The highest class is where you have the highest score. So you get the upper limit, and then you minus the lower limit of the lowest class. The lowest class is the class where we are going to have the least score, which is 10 to 20, like that. So you take this. Actually, the marks are ranging from 10 to 50. 10 to 50. So you hear like that, the range is what? 40. The range is going to be 40 for that particular case. So for group data, identify the highest class, take the upper limit. Identify the lowest class, take the lower limit. The difference between the upper limit of the highest class and the lower limit of the lowest class, it is going to give you the range, and your question ends there. That is the range. That is the range. I want us now to go to the next measure of dispersion. The next measure of dispersion, which is commonly asked in your exams, it is known as the standard deviation. The standard deviation. Standard deviation. It is actually one of those particular measures that are commonly asked for exams. So don't forget again, we have got the ungrouped data, and we have got the grouped data. I want us to start from standard deviation for ungrouped data. And actually, the dispersion I told you, it is how far the values are from the mean. And the dispersion is normally calculated as x minus x bar, where x is the individual value in the distribution, x bar is the mean. So as we go into this discussion of calculating the standard deviation, I want you to know that we cannot be able to determine the standard deviation before we get the mean. We must get the mean first, so that now we can be able to determine the standard deviation, because we need to get the x bar, and then the x bar that we shall get, we minus that value from each value of x that was in the distribution. So for ungrouped data, the standard deviation, normally denoted by something like that, is given by the square root of the summation of x minus x bar squared over n, where x is the individual value in the distribution. X is the individual value in the distribution. F bar is the distribution mean. It is the distribution mean. And then N is the number of observations. X bar is the number of observations. E.g., if you have a distribution like this, maybe it is 10, 15, 20, 25, and maybe 20, 24, and lastly maybe we have 26. And then you are told, find the standard deviation, or you calculate the standard deviation. As I said earlier, you cannot get the standard deviation before you get the mean. And this being ungrouped data, we have just come from a conversation whereby we were talking about how do we get the mean for ungrouped data. For ungrouped data, the mean, which is X bar, is calculated as the sum of the values. So it's going to be given by 10 plus 15 plus 20 plus 25 plus 24 plus 26. And then we divide by the number of observation, or the number of items we have. This is 1, 2, 3, 4, 5, 6. We divide by 6. So you will realize that our X bar is going to be given by how much, or what is the value? So this is 10, 15,
20.
Yes, you got?
20.
Okay. That's actually X bar is 20. Once you have your X bar, remember, anytime we find we have got this sign, anytime we have that sign, we say that simply means summation. That simply means summation. So in our formula here, it means as to have X minus X bar, we need to have the X minus X bar, and then we add them, or we sum them. But first of all, we have to square them first. We square them first, and then we shall actually add the values that have been squared. So, having obtained your X bar, it is now your responsibility to come here and have this. It is your responsibility to come here and have, we shall have X, which is actually the values. Remember, we said this is X1, X2, all the way up to X6. So you have them downwards. So you have 10, 15, 20, 25, 24, 26. Then after having the values of X, and we know we have X bar here, the next part is for you to get X minus X bar. And then we shall have X minus X bar squared. And that is going to be the end of that story. So if we know X bar is this and these are the values of X, for each and every individual value of X, we minus 20. That is what this one means. Every value of X, we minus the X bar. So if X is 10, what is going to be 10 minus 20? It is going to be what? Negative 10. Negative 10 squared is going to be 100. So the value you get here for X minus X bar, the same value you square to get X minus X bar squared. So when X is 15, we are going to have 15 minus X bar, which is 20, which is going to be negative 5 squared. It gives us 25. When X is 20, 20 minus X bar, which is 20, is going to be 0. 0 squared is 0. When x bar or x first of all is 25, you minus x bar, which is 20, you find is 25. 5 squared gives us 25. When x is 24, 24 minus 20 is 24. 4 squared is 16. And lastly, when x is 26, x minus x bar is going to be 26 minus 20, which will be 6. And therefore, square that, you get 36. So it is each and every value of x, you minus the x bar that you calculated. That's why we say you must start by getting the x bar. After getting your x bar, you can now proceed to get these particular 2 columns, and that is going to be the case. So, because the formula here is saying we sum x minus x bar squared, we have got the x minus x bar squared for each and every value of x. Each and every value of x, we have got the x minus x bar squared. So, we just add this. So this one is going to be equal to 150 plus 52. So this one, I think, is going to be 202. That is x minus x squared. That is the sum. Because we have added them, it gives us the sum. Once we have the sum, we can now get the standard deviation. Our standard deviation, therefore, would be given by the square root of x minus x bar squared, which is 202, over the x, the n, actually over n. N is the number of distribution. There were 6 numbers. So this one is going to be the square root of that 3.67. Which is going to be plus or minus 5.8. The standard deviation is normally plus or minus. It can be above or below the mean. That is how you get it. That is how you get it. The standard deviation from ungrouped data. The system on the sequence is clear. Get x bar first. After getting your x bar, come up with a table like this. You list down all the x values that you are given. From each and every value of x, you subtract the x bar that you have calculated, and you will be able to get the x minus x bar. But because the formula is talking about x minus x bar squared, the value for x minus x bar that you get, you square it. You square them, and what you need to note, x minus x bar squared, all of them will be positive figures. Because even if you square a negative, the answer will be positive. You just add all those, then you get the sum of x minus x bar squared. That sum is what you divide by the number of values that were in that distribution. You take the square root, you get the answer as that. And it is going to be the end of your discussion for that particular case. I hope that one is well understood. And I want
Excuse me, mwalimu.
Yes.
Hiyo either positive or negative 5.8 tumetoa wapi?
Square root ya 33.67.
Hiyo sio square root ya hiyo the above sum.
You know, I have divided 2 or 2 divided by 6 here. 2 or 2 divided by 6 gives you this. So if this is 2 or 2 divided by 6, then you pick the square root of that.
Okay, so thank you.
Yes. So that is when it is for ungrouped data. And don't forget, ungrouped data, it is when the values are just listed. You just separate the numbers by commas. That is ungrouped data. You simply get the mean by adding all those values divided by how many they are. You get the mean. That mean, take it now to the table, each and every value of x that you had here, minus the mean, the answer you get, you square, you add those squares, and then you get that. So we go to the next part, which is now for grouped data. The standard deviation from the grouped data. The standard deviation from grouped data. Grouped data is when we have got classes. When we have got the classes, let me look for a small question here, and then we see how it is done. We are given a table here of profit. That is the profit. And then you are given the number of companies that register the profit. Remember, this profit is in billions. And then you have got the number of companies that register that profit. That is going to be our frequency. Where we have 4, 7, 11, 15, 8, 5. Those are the companies that registered data, and you are asked from that particular data, you compute the standard deviation. We have not actually captured the formula. The formula for this particular kind of data, if you want to get the standard deviation for group data, it is normally given by the square root of f into x minus the summation here. Let me write it again. It is the summation of f into x minus x bar squared divided by the summation of x. That is how we get the standard deviation when it is for group data. And now this is where you need to be very careful, because this is what normally comes in the exam. Very rare you miss a question on the standard deviation. So, as usual, you must get x bar. That is where the discussion begins from. You must get the x bar, which is the mean. And we know from what we did in our previous discussion, we saw that x bar, which is the mean, is given by the summation of fx over the summation of f. That one has never changed. The mean, it is x, summation of fx over summation of f when it comes to group data. So that is what we need to do first. Let us determine our x bar. Let us determine our x bar, and then from there we shall see what will come next. For us to be able to get x bar, then we need a column for x, and we need a column for fx. That is a requirement. There is no other way we can be able to get the mean apart from having those two columns. So the x, we said, is the midpoint of the class. So if you have 8 plus 10 divided by 2, that is 18 divided by 2. Mine is going to be 9. This is going to be 11 plus 13 divided by 2. This is 24. Divided by 2 is going to be 12. This is going to be 14 plus 16 is 13 divided by 2 is 15. This one is going to be 18, 21, 24. Those are the midpoints, x. And actually, those are the values that we can use when we go to x minus x bar. Our x values are the midpoints that we have just computed. Having done that, we can get now our fx. Our fx, each value of f multiplied by x, fx. So, let me try to do it faster. 4 times 9 is going to be 36. 165. Comes to 843. That is the sum of fx, and the sum of f, because we did that here, is going to be there 50. So our x bar is going to be given by what? 843 divided by 15. It comes to what? 16.86 is our x bar. Our x bar comes to 16.86. Once you have that, let us call it 16.9. Let us call it 16.9. One decimal place for ease of computation. Once you have that, you just now go to your formula. You just proceed to your formula and do the necessary. So we need to be guided by the formula on what to do. At the end of the day, we need to get a column for f into x minus x plus square. That is what we need. We need a column for f into x minus x plus square so that we can sum the values in that particular column to get this particular numerator. We need a column for f into x minus x bar squared. So what you do, you start with like this. Just get x minus x bar, then get x minus x bar squared. Then now you just get f into x minus x bar squared. You just need that. Get x minus x bar. Whatever answer you get here, you square so that you can get x minus x bar squared. Then the answer you get here for x minus x bar squared, you multiply by frequency f to get f into x minus x bar squared. Then the values that are going to fall in this particular column, we shall sum them because the formula here says we sum those particular values down the table. So this is actually going to be the case. Our x, remember we said we use our mini points that we had computed. So it is going to be 9 for the first case minus x bar, which is 16.9. You get is going to be negative 7.9. The same value don't wrap, you just square it. You get 2.41. The same value, don't wrap it from your calculator, you multiply by f, which is 4. You realize it's going to be 249.64. 249.64 is going to be the value at the end there. You just go to the second row. The second row, our x is 12. So we do 12 minus x bar, which is at 16.9. You get it is negative 4.9. The same value you square because they say the same x minus x bar you got here. Now you square. So if we square that, you get 24.01. Then the same value you get here, x minus x bar squared, that you have here, you multiply by f, which is 7. You get it going to be 168.07. You come to this case where x is 15, and you do 15 minus x bar, which is 16.9. You you get is going to be negative 1.9. That value square it, you get 3.61. 3.61 is our x minus x plus square multiplied by f, which is 11. You get 39.71. We come to this row where x is 18. So we do 18 minus x bar, which is 16.9. We get 1.1 squared. It is going to be 1.21 times f, which is 15. You get is going to be 18.15. That. You come to this next row where x is 21, we minus x bar. 21 minus 16.9. You get 4.1 squared. You get 16.81 times f, which is 8. You get 1.4.48. You go to the last one where x is 24 minus x bar, which is 16.9. You get 7.1. You square that. You get x minus x bar squared, coming to 50.41. Then the value you get for x minus x bar squared, you multiply by frequency, which is 5. You get 252.05. After getting that, you need the sum for that column, because that is what is in the formula. So we add 134.48 plus 18.15 plus 39.71 plus 168.07 plus 249.64. You get there appearing to be 862.1. That is the summation of f into x minus x bar squared. That is the sum. So the sum is simply the addition of that particular column. Having obtained that particular column, you are now on the finishing line. You are almost there. You just come here and you say, therefore, the standard deviation will be given by the square root of 862.1, which is the sum of f x minus x bar squared, divided by the sum of f, which we have computed here as 50. So this answer that I have on the calculator divided by 50, I get it is going to be the square root of 86.21. So I do root answer. Sorry, root 86.21. It comes to plus or minus 9.28 or 9.3. And that is your answer. You rest your case there. It is actually very procedural. It is very procedural. First of all, get the x bar. The normal way we normally get the mean when it is for root data. Get that particular mean. After getting the mean, now introduce these three columns. X minus x bar. Then that is not what we need. We need x minus x bar squared. But again, that is not the end. X minus x bar you multiply by f. That is actually now what we require as per our formula. Then the values you are going to place on f into x minus x bar squared, you sum them because the formula says they are supposed to be summation. They are supposed to be the summation. Then you get the summation there, you divide by the summation of f. Whatever answer you get, you take the square root. It gives you the answer for standard deviation. These are all boosters. from the beginning of the unit up to this particular time, you have always been telling me that you are comfortable, and that is a very wonderful thing. We are past half of the syllabus, and if you are now okay,
Mwalimu, I have a question.
you are guaranteed of passing.
Mwalimu,
So, I want you to take the paper or the questions
Excuse
that
me,
I shared with you.
Ni kama kuna mahali tumekosea mwalimu.
Hapa tumekosea.
Standard Deviation.
862.1 divided by 50.
Inakuja 17 point something.
17.242.
You get what?
17.42.
Which is the figure here? This is not the
Where we get it. No.
Ni
Where we
hiyo
get
but umekosea kwa hiyo division.
Hebu moja aseme.
862.1 divided by 50, you get 17.24.
Oh. Okay. 862.1 divided by
50.
70. Okay. Actually, it is true. 17.24. 17.24. So we take the square root of that. The root of that answer is 4.15. Yes. That is how the answer was supposed to be computed. That is how the answer was supposed to be computed. And you have solved for your standard deviation. You will have solved for your standard deviation, and it is done. I was actually sending you to the other questions, even if they are not talking about standard deviation. As long as it is approved data, you can do some practice on the same and find out whether you are able to get the standard deviation. You are able to get the standard deviation. I think we can try one more. This last question I want to use for one of them. There's the last question, which is indicated as question 5, where we have the profits. You are given those as your figures for the profits that was earned by the company. Yes, I want all to do for company A. We do for company A. So we have the number of company A. We have got the frequency here: 20, 30. That is the distribution of the profit for company A. then I want us to use this particular data in calculating the standard deviation. So having known the formula for the standard deviation is given by SD is given by the square of summation of f into x minus x bar squared over the summation of f. We need now to proceed and have the values that we need, but always we need to first of all get the x bar, which is given by the summation of fx over the summation of f. So we shall start by getting the two columns that will enable us to get this. So we need the column for x, then we need the column for fx. So x is the midpoint of this. You realize the midpoint is going to be 10, 30, 50, 70, 90, and 110. If you add this 0 plus this one divided by this 10, this plus this one is 60 divided by 2, that is large. After getting that, we can get our fx. This one is going to be 200, this one is going to be 900, this one is going to be 500. It's going to be 1050. This one is going to be 1800. This one is going to be 55. 550. So if we add that, you get that, I'm getting 5,000. And then the summation of f, this is going to be 50, 60, 75, 80, 100. So the mean is going to be 500, 5,000 rather, divided by 100. So the mean is going to be equal to 50. That is our x bar. Our x bar is actually going to be 50. The fx divided by the sum of f. Having done that, we can now proceed and be able to get this particular numerator value. So, first of all, we do x minus x bar. Then we shall get x minus x bar squared. Then we shall finish. We shall finish by getting f into x minus x bar squared. And it is advisable you do it around the row so that you avoid a lot of wrapping and feeding the figures in your calculator. So our x values are this. For each and every value of x, subtract x, which is 50. So 10 minus 50 gives us 40. Square, this one will be positive 1500. Times the frequency, which is 20. We get that 2000. For this second one, the x is 30 minus x bar, which is 50, you get negative 20. Square, you get 400 times 30. You get 12,000. For the third one, it is x is 50. 50 minus 50 is 0. Square is 0. Everything will be 0 there. The other one is 70 minus 50, which gives us 20. Squared is going to be 400 times 15. It gives us 6,000. The other one is x is 90 minus x bar, which is 50, gives us 40. Square 1600 times 20 is about 2000. The other one is x minus x bar. X is 110 minus x bar, which is 50. giving us 60 squared, which becomes 600 times F, which is 5, it gives us 18,000. So having obtained those values, we just add all the F into X minus X squared, and we come and feed in our formula here. So if we add that, 18,000 plus 32,000 plus 6,000 plus 12,000 plus 32,000, it gives me 100,000. Are you getting the same? How many in your calculator?
Yes.
You are getting the same?
Yes.
Okay. If that is the value, then our standard deviation will be equal to the square root of 100,000 divided by the sum of F, which was 100. You realize that and that more. So it is going to be the square root of 1,000. Root 1,000. That's 1.62. You realize that it is giving us a figure of that nature, positive or negative, that's 1.60. And that is the end of the getting the standard deviation. So if you know how to get the standard deviation, then I will just mention the next two methods of calculating the dispersion. That is the variance and the coefficient of variation. Variance and the coefficient of variation. So if I can start with the first one, which is the variance. The variance, it is the standard deviation squared. So variance is simply the standard deviation squared. The answer of the standard deviation to square it, get the variance. Alternatively, if you want to calculate it for ungrouped data, the variance is normally given by the summation of x minus x bar squared over n. Without the square, we don't have the square. It is actually the same formula for standard deviation, but without the square root sign. For group data, the variance is going to be the summation of f into x minus x bar squared over the summation of f, like that, without the square. You calculate that. When you bring your answers here, you don't put any square root, and that is your variance. So variance, it is actually the standard deviation square. Because if you come and put this one and you square, the square root sign disappears. You know, if you put the square here, if you come and put this one and you square it, the square root sign disappears. If you find it difficult, you just calculate your standard deviation, and then your answer you square, you get the variance. So that one I will not show you if you have understood how to get the standard deviation. It is the same procedure. Just come up with the table like this, you get the answer, but when you now take it to the formula, don't put this square root. Or if you put the square root, you get the standard deviation. The answer for standard deviation, you square it, you get the variance. And then another measure that is very related to this particular concept of standard deviation is when you are asked to calculate the coefficient of variation, or what we normally refer as the CV, coefficient of variation. Coefficient of variation is given by the standard deviation over the mean times 100%. So CV is given by the standard deviation or SB, standard deviation over X bar times 100%. So if you are asked for coefficient of variation, so you will need to go through the whole process of getting the standard deviation. The good thing is that as you go calculate the standard deviation, there is that particular initial point whereby you have to calculate the mean. So this mean, and you have got the standard deviation there. So the coefficient of variation on CV, if this was the question asking that, you have got X bar, which is the mean as per the formula here. You have got the standard deviation. So in this case, the coefficient of variation was supposed to be that 1.62 over 50. Then we multiply by 100%. Period. You get the coefficient of variation. So the moment you have been asked to calculate the coefficient of variation, just know you'll have to go through the whole process of calculating the standard deviation. You calculate the standard deviation. The answer for standard deviation, you divide by the answer for the mean. It is going to give you the coefficient of variation by multiplying by 100, whatever you get after dividing. So that is the end of today's discussion. That is the end of today's discussion. When we shall meet next week, we shall do the decile, quartiles, and percentiles, and we end the syllabus.